go. What in the world is this? 39, okay guys? Okay. Probabilities involving outcome tables and tree diagrams. They are essentially telling us the same thing. So far we've explored probabilities involving the total outcomes of just one event. But what if there are more events happening simultaneously? For example, if you have two choices of a main meal and three choices for a drink, how many total possibilities are there? Well, it turns out that if you have two meals, that's your first event, first choice, and three drinks, right? You just go 2 times 3, there'll be 6 outcomes. 6 possibilities or outcomes, which we also call the sample space. That's very important. This concept right here is super important. So this could change, right? You could have 3 meal options and maybe 5 drinks. How many drink options are there at, I don't know, I'm thinking Burger King? Probably 6, right? So you just multiply, like if it's 3 meal options and 6 drinks, then it'll be 18, right, outcomes. So the more option you have for every decision, the more outcomes there are, okay? We can illustrate this using a tree diagram or outcome table. Here's your tree diagram, okay? So the first choice, this is your first event right here. This is event number 1. Okay, and this would be considered event number 2, where you have to choose a drink. Okay. So look at if you look at this is why this is a tree, it branches out, and so these are the roots here, and if you count the end roots here, you have 6 options, right? So I will make a note of that. 6 different outcomes. 6 different outcomes. And I can't do them all. I wanted you to do this tree diagram and copy it, and I thought, you know what, you're probably not going to appreciate that, so I'm just going to give it to you, right? But you could also add a dessert, right? You could add a dessert, ice cream, cheesecake, and a float, I don't know, right? So this would branch off into 3 again, right? So you can have more than 2 events. But I just had to keep it within reason, right? So I just wanted to maybe see if you can, right, just show that, right, the first 3 roots here, if you choose to go with meal 1, it branches off into 3 options for the drink, right? And if you choose to go with the second meal, right, those bottom 3 outcomes out of the 6 will all have the second meal, but then you mix it with the other 3 drinks. So we would still say that these are 6 unique outcomes. That's a tree diagram, guys. And I'll probably make you do one within reason. Next, this same concept can be illustrated using our outcome table. This is the more popular one, okay? So watch how I do this. It doesn't really matter, but I choose to put this first. So drink 1, meal 1. Followed by drink 2, meal 1. Followed by drink 3, meal 1, right? So these are all meal 1s, but the drinks, so these always meet here, and you get your unique outcomes and combinations. Here you have drink 1, meal 2, drink 2, meal 2, and you have drink 3, meal 2. And if I asked you how many outcomes are there, this is the box that gives you the outcomes. 6 outcomes. Okay. don't count, because sometimes I give students a box like this, like how many outcomes. They count all of these boxes, right? No, these are just your options, but the outcomes are inside here. Okay. Have you done these before? Anybody? Outcome tables, tree diagrams? It depends on, right? Some teachers, they do it, some don't. But I know you've done probability in younger grades. You have to have had probability, or else, right? But I think you're doing pretty good from what I'm seeing. Let's keep going. Top of page 40 is very important. I wish it would have been a little bit more in your face, but it is what it is. So here it is. Highlight this box because I will test you in some way if you understand this concept. Total number of outcomes. So you can replace outcomes with total number of passwords, total number of meals, whatever you want. You fill that in here. You need to multiply the options in the first event times the options in the second event, options in the third event, and however many events there are. So you could have, how many outfits can I have, right? Shirts, pants, socks, shoes, right? Maybe a cap. Maybe some of you wear a cap, right? So you have your options. So how many different outfits can you do, right? Me, I only probably have 5 shirts and 2 pants, right? And a couple of socks, that's it. My wife, on the other hand, right? I don't know. I can't count how many tops she has, but way more than me, right? So her outcomes would be a lot more than mine, right? All right, so let's put this to the test here. I'm done. When I'm done page 40, that's it for today. And you're just going to do a little bit of your own. So 2 4-sided dice are being tossed during a game. Okay. I'm going to make sure I stay on topic here. How many possible outcomes are there? And what's an alternative term for this, right? So we will say this. Die 1 is basically our first event. Times, dot is times for us, okay? Die 2 is our second event. In this case, they're both 4-sided. So there's 4 options there, 4 options there, 16 outcomes. And this is called sample space. Sample size, sample space, the same thing. So if I had a 6-sided and another 6-sided, then it'd be 6 times 6, 36 outcomes you could have. So if you're into board games, this is going to help you take your game to the next level, right? So it says create an outcome table showing all possible outcomes. So you go like this: 1, 2, 3, 4. And so that would be die number 1. And then die number 2. In this case, they happen to be exactly the same. I could just be careful. I could do a spinner. Hey, you spin a spinner and you roll a die. So red, blue, green, whatever, and rolling a 6-sided die. It doesn't matter. It works the same way. So your outcomes would be in here. 1 and 1, right? 1 and 1, 2 and 1. You can roll a 3 and a 1, as well as a 4 and a 1. So these are your combinations here. It's like meal 1, drink 1, okay? You go back up. This is 1, 2, 2, 2, 3, 2, 4, 2. Whatever pattern you choose, stick with it, right? And so I'm going to go 1 and 3 is an option here. rolling a 2 and a 3, a 3 and a 3, as well as a 4 and a 3. And your last one is 4 and a 1. Sorry, I don't want to mix it up. Okay, so this number first: 1 and a 4, 2 and a 4, 3 and a 4, 4 and a 4. So you can clearly tell, if you count, you just multiply, right? 4 times 4, there are 16 outcomes here. And now we can use this to find out some probabilities. I'm just going to make a note here. I'm looking at my original. This is die 1, and this here is die 2. Die 1 and die 2. Now, state the probability, guys. Probability of rolling a sum that is greater than 6. So a sum that's 7, 8, and right, anything bigger than 6. I'm going to call this G6. Okay, G6. Isn't there a Pontiac G6 or something like that? Anyways, G6. So probability of getting a sum that's greater than 6. I know without even looking at the chart that there are 16 options, right? That is a given. And watch this. Look diagonally. Always look diagonally. Watch. This adds up to 2, right? These add up to 3. All of these add up to 4. You see that? All of these here add up to 5, 6, 7, right? These add up to 7 here. 7 and 7, and this would be 8. So your sums greater than 6 are actually right here. I'm going to use a highlighter for that. So G6, right, is right here. These combinations here will result in a sum greater than 6. How many do we have? 1, 2, 3. 3 combinations. 3 out of 16. Bingo. There, you're done. What are the odds of greater than 6? Use your probability here. Use this. 3. And on the other side, you go 16 minus 3. You take your total, you subtract what is there. So 3 options give you sum greater than 6, and 13 options do not. I cannot give you all the examples, but if it had said what's the probability of rolling a sum of 6, exactly 6, that's different. Then you're just, oh, 1, 2, 3, these 3 here would have been exactly 6. Let's answer a couple more. Which sum is most likely to happen? Show how you know. You figure it out, look, and then I'll tell you, right? You look diagonally this way. So I would say a sum of 5 is most common because you have 1, 2, 3, 4 options, right? Here you have 3 options, 2, same thing this way, 3, 2, 1, right? So this is the most common right here. Probability of a sum of 5 That would be 1, 2, 3, 4 options, which is 0.25, which is 25%. I will use a different highlighter for that one. Most likely to happen is a sum of 5. Oops, you can't see that, can you? There, sum of 5. So I will just a sum of 5, right, is most likely. So if you play Settlers of Catan, right? I don't know if you play that game, it's a board game. You do sums all the time. You roll 2 dice and then you get your numbers on a certain tile and you get the resources that you're around. Okay, so there the sum is 7 and 8 will actually, no, not 8, 7, 8. 8 will be kind of, it will be a bigger number because they're 2 6-sided die. So it changes based on your options. Okay? Next, state the probability of rolling doubles. So rolling doubles, the name says it all, rolling a 4 and a 4, 3, 3, 2, 2, 1, 1, right? So probability of doubles, you will probably realize that it is the same probability as the one before, right? In this case. So you've got 1, 2, 3, 4 doubles. I'm going to use a different color for that one, doubles. Four options there. Okay, so I'm just going to ask you to try page 41 and 42. Just work on those questions, page 41 and 42.